Good afternoon to everyone. My name is Patan Akbar Kalandar Khan. I am studying B.Tech in Srinivasa Ramanujan Institute of Technology in the stream of CSE. Today my topic is breadth first search algorithm with examples. Subject name data structures and algorithms. Breadth first search algorithm with example. Introduction to BFS. Breadth first search BFS is a graph traversal algorithm. It explores all the neighbor nodes at the present depth prior to moving on to nodes at the next depth level. BFS is commonly used in various applications, including finding the shortest path in unweighted graphs. Key concepts. BFS uses a queue data structure to keep track of nodes that need to be explored. The algorithm begins at a selected starting vertex and marks it as visited. If then explores each unvisited neighbor, adding them to the queue for future exploration. BFS algorithm steps. Start by initializing a queue and enqueuing the starting node. While the queue is not empty, dequeue a node and explore its neighbors. Mark each neighbor as visited and enqueue them if they haven't been visited yet. BFS pseudocode. The pseudocode begins with initializing a queue and a visited list. Enqueue the start node and mark it as visited before entering a loop. The loop continues until the queue is empty, processing each node's neighbors. Example graph structure. Consider a simple graph with nodes A, B, C, D, and E. The connections are as follows. A connects to B and C. B connects to D and C connected to E. This structure will help illustrate how BFS explores node systematically. BFS example initialization. Start BFS traversal from node A in the provided graph. Enqueue node A and mark it as visited. The queue now contains A. First iteration of BFS. Dequeue node A from the queue and explore its neighbors B and C and C. Both B and C are unvisited, so enqueue them and mark them as visited. The queue now contains B, C. Second iteration of BFS. Dequeue node B and explore its neighbor D. D is unvisited, so enqueue it and mark it as visited. The queue now contains C, D. Third iteration of BFS. Dequeue node C and explore its neighbor E. E is unvisited, so enqueues it and mark it as visited. The queue now contains D, E. Conclusion of BFS. Continue the process until the queue is empty. Visit nodes in the breadth first order. The final traversal order for the example graph is A, B, C, D, E. BFS is efficient for finding the shortest path in unweighted graphs and can be adapted for other applications. Free to modify or expand on any of the points for your presentation. Thank you.